Hi and welcome back to this channel. So today we'll be talking about scheduling algorithms. So for this scenario, we want to think about how best to schedule jobs. Let's say we have n jobs and our input would be n jobs waiting to be done in a queue, and each job, where every ith job has a starting time, let's call this a starting time, and a finishing time, fi and si, starting time and a finishing time. And we don't want to do two jobs that overlap, right? So when we have two jobs that overlap, for example, this job and this job overlap, so we choose one. We don't want to do two jobs that overlap. We choose one of the jobs, and our goal is to, what is our goal? Our goal is to maximize the number of jobs we execute. We want to maximize the number of jobs we execute. So I think this is something to think about. So if you can, pause this video for about 45 seconds to 1 minute. Think about it. If you have n jobs, each job has a starting time and also a finishing time, and your goal is to maximize the number of jobs you execute, and you want to execute these jobs in such a way that they do not overlap. How would you schedule these jobs? So think about it, pause, think about it, and come back. So let's talk about our strategies. We'll talk about this problem using different strategies. So the first strategy, what if we decide that we want to execute our jobs in first come, using the first come, first start strategy? That's let's call it FCFS, first come first start strategy. That's, we want to execute the job in the order in which they have been queued. Yeah, we want to execute these jobs in the order in which they have been in the order in which they have been queued. For example, if we have job A, then job B, then job C, that is how we want to execute them. First come, the first come first start. But I have a question. There's something we should think about. Supposing we say, well, we should execute it first come, using the first come first start strategy. What if we have our first job? Let's say this is our first job. What if our first job overlaps all the other jobs? Let's say this is the first job, then this job, then another job, then another job. Using this strategy, first come, we see that this job comes first, then this one, then this one, then this one. But then we see that our first job tends, to execute forever. While thinking about the strategy for solving this problem, we have to keep in mind our goal, which is to maximize the number of jobs we execute. If we use this strategy, this first come strategy, are we going to be achieving our goal, which is to maximize the number of jobs we execute? Because apparently, if we execute this first job, it means we are not going to execute the second, third, and fourth job. So what do you think? Would you rather execute only the first job, or execute all the other jobs? That's the question. So while you think about that, let's think about another strategy. Our second strategy, let's call that the shortest jobs first. Supposing we want to execute the shortest jobs first, which is also a good strategy. But again, what if we have, let's look at this example. We have a first job, we have a second job, and we have the third job. So if we want to execute the shortest job first, that would mean we want to execute this one first, the second job first. We want to execute the second job first. But if we execute the second job first, it means we would neither execute the first job nor the third job because they overlap with the second. So keeping in mind our goal, does this maximize the number of jobs we are executing? I don't know. You just think about it. So let's think about the third strategy. Strategy 3. And for third strategy, let's say we want to execute smallest degree first. Smallest degree first. And by degree, we mean the number of intervals that interlap with each job. For example, if we have, just like in the last example, the shortest job first, if we have this, we can say that the degree, let's call this job A, job B, no, this would be job B and job C. So we would say that the degree of job A would be 1 because it only overlaps with job B. The degree of job B will be 2 because it overlaps with job A and job C. And the degree of job C is 1 as well because it only overlaps with job B. So with this strategy, we want to execute smallest degree first. So that will mean we want to execute job A, then job C. And for this example, it works, right? Because if we execute smallest degree first, we have maximized the number of jobs we are executing. But let's paint this scenario. If we have, just take a look at this scenario. Supposing we have these jobs, yeah, and we have this one. We have this one also. We have this one. And here we have this. And here we also have this. Let's think about this. This has degree 3. This has degree 4 because it overlaps with this, and this. This has degree 4 also because it overlaps with this, and this. And this has degree 3. This has degree 4, degree 2, degree 4, degree 4, degree 4, degree 4, and degree 4. Yeah, and we want to execute smallest degrees first. What does that mean? Does that mean we will execute this and we execute this using smallest degree first? We execute the job with degree 2, we execute this job, we execute this job, and that will be all. So we say that if we use smallest degree first with this problem, we only do 3 jobs, but the maximum number of jobs we can do is 4 jobs, because I mean, if we weren't following smallest degree first strategy, we could have just executed this job, this job, this job, this job, because these 4 jobs do not overlap. So we can't say, looking at this example right now, we cannot say that smallest degree first is the best strategy for, we can't say that smallest degree first is our best strategy. So what other strategies can you think about? I think we should, we're going to end this video here, and we'll talk about the other strategies from the next video. If you liked this video, do well to subscribe, comment, share with your friends, and I'll see you on the next one.